We can stop HIV, Iowa. Unfortunately, there are barriers that make our job a little more difficult.
Stigma is one of our biggest challenges.
So we should talk about HIV more.
And support people living with HIV.
Visit stophiviowa.org.
This is SpaceTime Series 25, Episode 78, for broadcast on the 15th of July 2022. Coming up on SpaceTime, discovery of the fastest known star. Physicists confront the neutron lifetime puzzle. And shedding new light on dark matter. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have discovered the fastest known star in the galaxy. The star, known as S4716, orbits Sagittarius A star, the supermassive black hole at the center of our galaxy, taking just 4 Earth years to complete each orbit, in the process reaching speeds of around 8,000 kilometers per second. The discovery, reported in the Astrophysical Journal, also shows that S4716's orbit brings it to within 100 astronomical units of the black hole. An astronomical unit is the average distance between the Earth and the Sun, which is around 150 million kilometers. And considering Sagittarius A star has some 4.3 million times the mass of the Sun, that orbit's extremely tight by astronomical standards. In this area surrounding the black hole at the center of the galaxy is a densely packed cluster of stars. Known as the S cluster, it's home to well over 100 stars that differ in their brightness and mass. All S stars are especially fast. The study's lead author, Florian Pesca from the University of Cologne, says that one prominent member, S2, behaves sort of like a big person sitting in front of you in the movie theatre, blocking out your view of what's important. The view into the centre of our galaxy is therefore often obscured by S2. However, in brief moments, astronomers get to observe the surroundings of the central black hole. By continually refining methods of analysis, together with observations covering almost 20 years, astronomers have now identified a star that travels around the central supermassive black hole in just 4 Earth years. The authors needed 5 telescopes to observe the star, with 4 of these being combined into a single large telescope, allowing more accurate and detailed observations. Pesca says for a star to be in a stable orbit so close and fast in the vicinity of a supermassive black hole was completely unexpected and marks the limit of what can be observed with traditional telescopes. Importantly, the discovery also sheds new light on the origin and orbit of fast-moving stars in the very heart of the Milky Way. The study's co-author Michael Zaschek from Masaryk University in the Czech Republic says the short-period compact orbit of S4716 is quite puzzling. He says stars simply couldn't form very easily that close to a black hole, so S4716 needed to migrate inwards to reach its current orbital position. He thinks it did this by approaching other stars and objects in the S cluster, which then caused its orbit to be perturbed and shrunk significantly until eventually it ended up where it is now. This is SpaceTime. Still to come, physicists confront the neutron lifetime puzzle and shedding new light on dark matter. All that and more still to come on SpaceTime. To solve a long-standing puzzle about how long a neutron can live outside an atomic nucleus, physicists entertained a wild but testable theory proposing the existence of a right-handed version of our left-handed universe. They designed a mind-bending experiment at the United States Department of Energy's Oak Ridge National Laboratory to try and detect a particle that had been speculated about but never actually seen. It found the theorized mirror neutron, a dark matter twin to the neutron, could explain a discrepancy between answers from 2 different types of neutron lifetime experiments. and it would also provide the first observation of dark matter. Now, as we've discussed at some length this week on SpaceTime, dark matter is a mysterious invisible substance which makes up some 80% of all the matter in the universe. Scientists have no idea what it is, but they know it exists because they can see its gravitational influence on normal matter, preventing galaxies from flying apart as they rotate. The study's lead author, Leah Browsard, says dark matter remains one of the most important and puzzling questions in science. Clear evidence that researchers don't fully understand nature. Neutrons are commonly found with protons in the nucleus of atoms. However, like protons, they can also exist outside the nucleus. Last year, using the Los Alamos Neutron Science Center, the study's co-author Frank Gonzalez, who's now at Oak Ridge, made the most precise measurements ever on just how long free-floating neutrons can live before they decay, turning into protons, electrons, and antineutrinos. It turns out the answer is 877.8 seconds, give or take 0.3 seconds. That's a little under 15 minutes. And it hinted at a crack in the standard model of particle physics, the foundation stone of science's understanding of the universe. It describes the behavior of subatomic particles, such as the three quarks which make up the neutron. The flipping of quarks initiates neutron decay into protons. The neutron lifetime's an important parameter in the standard model because it's used as an input for calculating the quark mixing matrix, which describes quark decay rates. If the quarks don't mix as expected, it would suggest hints of new physics beyond the standard model. To measure the lifespan of a free neutron, scientists take two approaches which theoretically should arrive at the same answer. One simply traps neutrons in a magnetic bottle and counts their disappearance. The other counts protons appearing in a beam as neutrons decay. The problem is, it turns out, neutrons appear to live 9 seconds longer in a beam than what they do in a bottle. And that simply shouldn't happen, so why the discrepancy? One hypothesis is that the neutron's transforming from one state to another and then back again. Oscillations are quantum mechanical phenomena. If a neutron can exist as either a regular or mirror neutron, then you get oscillation, a rocking back and forth between the two states. So the Oak Ridge team performed the first ever search of neutrons oscillating into dark matter mirror neutrons using a novel disappearance and regeneration technique. The neutrons were made at the Spallation Neutron Source, a Department of Energy Office of Science user facility. A beam of neutrons were guided to a magnetism reflectometer. The instrument applied a strong magnetic field to enhance oscillations between neutron states. Then the beam impinged on a wall made of boron carbide, which is a strong neutron absorber. Now, if the neutron does in fact oscillate between regular and mirror states, when the neutron state hits the wall, it will interact with atomic nuclei and get absorbed into the wall. However, if it's in its theorized mirror neutron state, it's dark matter that won't interact. So, these dark matter or mirror neutrons would easily make it through the wall to the other side. It would be as if the neutrons had gone through a portal to some dark sector, a figurative concept used in the physics community. The dynamics are the same on the other side of the wall, where the authors try to induce what are presumably mirror neutrons, the dark matter twin state, to turn back into regular neutrons. The discovery of any regenerated neutrons could therefore be a sign of the particle nature of dark matter and an incredible discovery. Sadly, the findings, reported in the journal Physical Review Letters, showed no evidence of neutron regeneration. And all 100% of the neutrons were stopped, with 0% passing through the wall. Of course, in physics, that's not a failure. It simply eliminates one hypothesis, so we don't have to do that one again, and therefore helps advance knowledge. And with one particular mirror matter theory debunked, scientists can now turn their attention to others as they continue to try and solve the neutron lifetime puzzle. And Prasad says her team will continue looking for a reason to explain the discrepancy.
If you're the average person and you think about a portal, you're thinking about what you might encounter in a story or in a movie where you're about to go to some strange new world because you're going to be traveling through space and time. But for a particle physicist, when we use the word portal, it's figurative. We're looking for new ways that the matter we know and understand that makes up our universe might interact with the dark matter that makes up the majority of our universe, which we don't understand. When the stories about my research first came out, it actually coincided with the release of a very popular TV show called Stranger Things. I think for a lot of people, they could draw these very strong parallels between what was happening in the show, where we're opening portals to other dimensions, and my research. And so actually, I was contacted a lot by people who wanted to volunteer to go into the other dimension and explore. But that's not what my research is about. We're looking for the possibility that a neutron can go through a wall. And we just have basically a tube with a blocked end. And so this neutron goes through this tube in the middle of this magnet, and we expect that all neutrons should just be stopped. And so if you see anything on the other side, the neutrons must have had some way, some portal that allowed them to pass through. So the question I get the most is, were we successful in opening the portal? And unfortunately, no, we did not find any evidence of parallel universes or new interactions with the neutron and the dark sector. But of course, it's still possible that the neutrons are turning into dark matter in a way our experiment wasn't sensitive to, so we are still planning more sensitive searches and more in future experiments at the high-flux isotope reactor.
That's Leah Prasad from the United States Department of Energy's Oak Ridge National Laboratory. And this is SpaceTime. Still to come, shedding new light on dark matter, and later in the science report, a new study looks at who's more likely to develop long COVID. All that and more still to come on SpaceTime. A team of scientists have developed a new method for predicting the composition of dark matter. The new research, reported in the journal Physical Review Letters, looks at predicting cosmological signatures for models of dark matter with specific masses between that of an electron and that of a proton. Previous methods had predicted similar signatures for simpler models of dark matter. But this research establishes new ways to find these signatures in more complex models, which experiments continue to search for. The study's lead author, Cara Giovannetti from New York University, says experiments searching for dark matter aren't the only way to learn more about this mysterious substance. Precision experiments of different parameters of the universe, for example, the amount of helium in the universe or the temperature of different particles in the early universe, can also teach us a lot about dark matter. Giovannetti and colleagues focused on Big Bang nucleosynthesis, the processes by which light forms of matter, such as helium, hydrogen, and lithium, are created. Giovannetti says the presence of invisible dark matter affects how each of these elements will form. Also vital to these phenomena is the cosmic microwave background, the electromagnetic radiation generated by combining electrons and protons that remained after the universe's formation. According to Big Bang theory, temperatures and pressures during the first 270,000 years of the universe's existence were so hot atoms couldn't form. Matter was instead distributed as a highly ionized quark-gluon plasma, which was very efficient at scattering radiation. This meant that photons from the early universe were effectively trapped in an impenetrable fog, which to this day still hides these early times from astronomers. But as the universe expanded and cooled, temperatures and densities dropped to a point where atomic nuclei and electrons could eventually combine to form the first atoms. This is known as the epoch of recombination, and it's at this time that photons were finally able to escape the fog of the early universe and travel freely. The cosmic microwave background radiation is a record of these photons at the moment of their escape. The authors sought a means to spot the presence of a specific category of dark matter, that with a mass between that of an electron and that of a proton, by creating models that took into account both Big Bang nucleosynthesis and the cosmic microwave background radiation. Giovannetti says this type of dark matter should modify the abundance of certain elements produced in the early universe and leave an imprint in the cosmic microwave background by modifying how quickly the universe expands. In their research, the authors have made predictions about cosmological signatures linked to the presence of certain forms of dark matter. They say that these signatures will be the result of dark matter changing the temperatures of different particles or altering how fast the universe expands. Their results show that dark matter that's too light will lead to different amounts of light elements than what astrophysical observations can see. Giovannetti says lighter forms of dark matter might make the universe expand so fast that these elements don't have a chance to form. She says her team will learn from their analysis that some models of dark matter can't have a mass that's too small, otherwise the universe would have looked very different from the one we see today. I guess only time will tell. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. Scientists have determined that you're more likely to develop long COVID if you're female, had poor physical and or mental health before the pandemic, and are aged 50 to 60. The findings, reported in the journal Nature Communications, are based on data from 10 studies, including a total of 6,907 people and 1.1 million electronic health records to investigate long COVID risk factors. In the 10 previous studies, long COVID occurred in between 7.8 and 17% of COVID-19 patients, with between 1.2 and 4.8% reporting debilitating symptoms. However, in the electronic health records, only 0.4% of COVID-19 cases develop long COVID. But the authors say this is probably because the condition wasn't recognized in these records until December 2020. Over 6.4 million people have now been killed by the COVID-19 coronavirus since it first appeared in the area around China's Wuhan Institute of Virology back in September 2019. However, the World Health Organization says the true death toll is likely to be around 15 million, with more than 546 million confirmed cases globally. A new study has identified almost 1,000 species of bacteria and archaea that are living on glaciers in the Tibetan Plateau. Glaciers have traditionally been considered extreme environments where little life can exist. But the researchers, reporting in the journal Nature Biotechnology, found a wide range of bacteria in these environments. The authors say the discovery could have public safety implications, as melting glaciers could release these bacteria into rivers and streams where they could interact with other bacteria, as well as local plants, animals, and humans. The authors say further analysis is urgently needed to evaluate the impact of global warming on water quality. Scientists at the University of Cambridge have developed a new low-cost supercapacitor that can selectively capture carbon dioxide gas while it charges, and then releases the gas in a controlled manner when it discharges, thereby allowing carbon dioxide to be collected and reused or alternatively disposed of responsibly. The supercapacitor, which is similar to a rechargeable battery, is only about the size of a coin and is made in part of sustainable materials including coconut shell and seawater. The supercapacitor consists of 2 electrodes of positive and negative charge. The new device could help power carbon capture and storage technologies at much lower costs than existing technologies, which require large amounts of energy and are expensive. Scientists found that by slowly alternating the current between the plates, they could capture double the amount of CO2 compared to previous devices. Well, they say if you remember the 60s, you probably weren't there. And it seems the tensions of the Cold War were causing the world's militaries and spy agencies to try out some fairly wacky ideas in the realm of the paranormal in order to gain an advantage over the enemy. And it wasn't just the CIA and KGB. The Brits were in there too. Tim Mendham from Australian Skeptics tells us the story of British psychiatrist John Barker from the UK Society of Psychical Research and his work looking into the dreams and forebodings of people who claim to have had premonitions.
Yeah, they were doing all sorts of things, actually, not just necessarily spy boffins either, but they were definitely involved with it. CIA tests, the Russians were doing it, trying to find out the reality of psychic powers and that sort of stuff, especially remote viewing things, which is handy if you want to know where an army is that's going to attack you. The particular case that's sort of been talked about in a recent book is of a gentleman who was around in the mid-60s named John Barker, who was a psychiatrist who was working on a book about people who appeared to have scared themselves to death, which is an interesting concept. Basically, he heard about, and as a lot of people did in 1966, if you were around at the time, if you're of a certain age, whereas the Aberfan mining disaster, where a huge slag pile of, is it coal or whatever's been mined out of Aberfan, probably coal.
It was coal.
Coal collapsed. It just became an avalanche and fell down, particularly on a school, killing 116 kids and 28 adults. And the suggestion was that many people had premonitions that this was going to happen, this guy doing his research. Therefore, it becomes an interesting experiment to see if there are such things as premonitions.
Yeah, but how many times have you answered the phone to somebody and you say, I was just thinking about you?
Yeah, often.
Yeah, it's the same thing.
I do it all the time. Yes, I know. You do have premonitions. The question is you forget the ones that don't work and you remember the ones where that person is on the phone, etc. But I mean, so therefore they were trying to sort of quantify these premonitions to people. They're asking people to send in their premonitions, etc. They collected 723 predictions over a 15-month period, of which 18 were recorded as hits. So 18 out of 723, which is actually less than what we found in our survey of psychic predictions, which we published at the end of last year, which you can see on our website, skeptics.com.au. And that we looked at 3,000 predictions over a period of 20 years, made by 200 plus psychics, etc. Psychics in quotes, people who say they're psychic. And we assessed them. Did it come true? Was it plainly obvious that the country was so vague you couldn't pick it? And we came down with a figure of about 10%, which you could class as true, as this actually happened, but it's not a very good hit rate. Imagine if your doctor was right 10% of the time, you'd probably choose a different doctor. All doctors were right 10% of the time. You'd worry about the whole profession. Same with your car mechanic. But this success rate was a lot smaller of their predictions, so it's even less impressive. Some of the hits were good. Some of the hits were pretty good, pretty convincing, but you can't base a profession on a couple of good results, although a psychic will always tell you how well they did on this particular prediction and how impressive it was. They won't tell you all the 3,000 times they failed miserably. The others have been checking this up for some time, and Russian investigators and all sorts of people like that have been looking into the possibility. So we did it too, being skeptics, putting on our little lab coats, etc., and went out and assessed all these sort of predictions and found out that they're not very good at it. And this particular thing, I think he found they're not very good at it. But the trouble is, you cherry pick out the successes. There were two they quote in this particular book out of 700 odd, and you say, see, that proves it. Well, it doesn't actually. It proves it doesn't work 726 times out of 728. So you cherry pick out the good results and you ignore the other ones, and that's not a very scientific approach. So that's what this guy did, and it's interesting, but that's about it. Nice to try it out. Premonitions, forebodings, all that sort of stuff. I mean, they set up a premonitions bureau in a way to actually formally study this, which is good, worthwhile doing. I'd agree with formally studying, but don't expect a great result, and this result was certainly not great.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.